So what I might do is, you know, somewhere in about here, drill through all of this clamped together. Drill through and then run the solid brass in, which will help weight this just a little bit to the back, in addition to looking absolutely magnificent in this somewhat discolored, but this white maple, and then, or white-ish maple, and then doing a small pin and a small pin, or taking this or a bit of quarter-inch copper water pipe, quarter-inch outside diameter, drilling through for that, sliding the copper pipe through here as a lanyard hole. That'd look kind of stylish. That'd be nice. If we are going to do that, then this is all going to get roughed up so that the epoxy has a real good surface to it, and then we're also going to skeletonize some of this. So that, you know, there's more places for the epoxy to go and get through. It isn't just like mustard in a sandwich where it's all slabbed onto one side and then there's something else on the other side. We want it all to homogenize and to soak into the wood all the way through so that there's mechanical connections of pins as well as the elastic qualities of the epoxy inside. I went a little bit long there. So, as I was saying, if the holes for the pins are drilled, it'll be like one large solid here, and then a small solid and a small solid, or it'll be hollow for a lanyard hole, so a pipe will go through, solid, a large solid, and then a small pin here. That's the general idea for that. And if that's the case, then all of this is going to get roughed up so that the glue binds to it. And then it's also going to get skeletonized so that the glue has a chance to commingle through the wood, through the handle, as well as the mechanical connections of the pins. I don't have any really great pre-planned material. So what I have is this aluminum block that was part of a liquid cooling unit for a PC. It's plenty big enough, as you can see, to guard my whole hand. So I may cut this out to shape and then put it on top and then run some connections through here. Again, probably brass stock, and fit the handle up to it, or fit the handle and this up to the blade. I may do that. That's realistically what I should do. The hard part is that, no, I'll just cut all this out into a big egg shape inside here to start, and then we will pin it to this. We'll drill it and pin it to this. You know, I'm really just screwing around. That's the problem. Let's cut this out. Let's fit it to the piece, to the blade, and then let's worry about how it goes onto the handle. Now, one of the things that's terrible is when these things rattle. They rattle because of loose connections. Like, there'll be a hole in this and it'll just sit up like this, but there'll be a little bit of give, and they're like, oh, let me just glue that in. So what we would do is in here, we would drill a couple of pinholes. Yeah, somewhere in there. Right up underneath of this, like 1, 2, and then 1, Yeah, well, yeah. Something like that. And then you'd slide the handle over it so nobody would see it. It's not really ideal for this, though. And this is going to be too big. This is going to be too large for me to drill through and pin it to the handle. I may just go with a block of wood. We may just use a second block of wood up here as the handguard. Okay, 63 millimeters turns into 31 and a half. This is anodized. It's harder than I expected. Alright, you can't see it, but trust me, it's there. Okay, it'll be easier to see this time. So, the full width, 63. So we're going down to 31 and a half. Can't really see it, but it's there. And then the half, I recall this is 80 something, 79. Okay, call it 80. We'll go down to 40. Lock it down. Come to the edge. There we are. So there's the center line and the rest. You can't see it yet. It'll make sense. So this drill bit is the exact thickness of this blade. So we're going to make another marker in a minute for the width of the blade where it's going to go in, and then halfway out, and then halfway out. I'm going to drill a series of holes like this down the line that you can't really see yet. And from there, it'll be a lot easier to just use a Dremel tool or an end mill. I don't think I have an end mill this small, but I'd use an end mill and chew through that. We'll probably use a Dremel. God willing, it will cooperate. That's that. Okay, so you can't really see it, but right there, and right there. You can just kind of make it out. That's fine. So anyway, this, from this dot to center to this dot is where the blade is going to be slotted in. And then basically, I'm just going to go out from here. Actually, I'm going to go from here to here. And I'm going to make a circular handguard for it because it's simple. It's not very exciting. So approximate handguard. I may exaggerate this and come out to here and then down, but this is the slot for the actual blade itself. Center point, outer edge, outer edge. I will actually, this would look much cooler with a kind of egg-shaped handle. Let's see what that looks like. Oh, that'll look weird. So, you know, it'd look kind of like that, except it'd have these broad, flat sides. I don't know, maybe that's not as good. Maybe it's not as good. Doesn't matter. That's later. Okay, so this is a very small drill bit, right? This is incredibly small. So in order to make life easier, because every time you try to drill, there's deflection, where this is spinning and it's long, and where there's resistance, it'll want to skip across a flat surface. So we're going to use this tiny bullet-headed piece of hardened steel round stock to create a center punch, which is the hole that helps guide the bit, the very tip of the drill bit, in so it doesn't skip around and do nasty stuff. I can hear people outside, but I can't tell if it's normal people outside or if I need to go outside. So basically, from just inside this point, I'm going to go bang. Just inside this point, I'm going to go bang. And then as close as I can do it together, I'm going to do dozens of these all the way in. And then from here, all the way in the hopes that I can make a nice straight line and that I will be rewarded. I'm not going to, well, I'll do one. I don't know that anybody's excited about this, but we'll go with the center, just like that. And it's very important you only do one per hit. You do not keep hammering it because it makes the hole stupid, irregular, and unstable. Okay, so I don't know how well you can see that, but that's not a very straight line. It irritates me, but it probably won't matter. Chances are it won't, because the drill's going to go through, and once the drill goes through, I've still got to cut out the little tabs of metal that are between each drill hole, which is going to take a rotary tool, which is not a thing I have a lot of skill with. So this hole may get opened up. There are a couple of ways to deal with that. When I'm done with getting this dry fitted up, I will, and cut, I will show you what they are, because they're kind of trashy. They're not my favorite, but we might have to do it. I don't know if you can see that. Oh, there you go. Okay, so you can see the line now. Now I've got this squared up. I've run out of hands, so I can't do everything, but basically, and within the adjustments of, this is not super science. This machine is very old. It's going to allow us to bore basically a straight line, which is fine because we're still cutting a circle out of this when we're done. So if I'm off by a little bit, it's not a big deal. You know, standard rules, and make sure this is all clipped down. Make sure this is secure. Get your WD-40 ready to lubricate the cuts, because you're going to make a lot of cuts. Don't force it. If it makes weird sounds, just pull out. So, there it is. Looking nice and flash in the literal. Throw my holes. Did you know that you can drill holes with a broken drill bit? You just have to apply enough WD-40 and stupid to the situation. Suddenly, everything's fine. Or not fine, but solvable. Anyway, next step. Okay, so I bought this the other day, and believe it or not, I've never really used a Dremel tool. I mean, I've used the giant pneumatic thing in the shop, which is like this big and would cut through steel if you let it. But doing fine work, this is actually out of my range of expertise. So we're going to try one of these little bits and try to just do my cuts. And we'll see how it goes. Okay, well, this hideous wound took vastly longer than I would have liked and came at several costs. Next time, just buy the milling machine bit that you need, use an end mill, make a penetrating cut, and then do a slot. Now, normally, people on TV or the internet would just take this round thing and they would just grind everything down. If I'd been smart, I would have put it on the lathe and chewed this off with an end cut type tool. I'm going to use a bandsaw and just trim, and then use the sander to do the points and edges as they remain, because I need to save some time on this. Okay, so there it is. It's badly misshapen, but I'm going to round it up. And then we've got to work on the blade a little bit. Well, on the ting, not the blade. Yep. Okay, so we're going to pre-drill our holes. This is a 1/4 inch drill bit, half size, because we're going to go up to a 1/2 inch total. This will be a 1/4 inch drill hole that will go up to a 1/2 size total, 1/4 inch drill bit. It's really not that exciting. This is secured. This is secured. Everything else is pretty stable. Okay, so you know how sometimes you just really want a fucking solution and you're not really doing the smart people thing? This is the upper half of a machete. This whole blade is hardened. So naturally, it does not want to be drilled through, and I have been ruining tools doing this.